Hello friends, welcome to my lecture on testing of hypothesis. This is second lecture on testing of hypothesis. Let us discuss first level of significance. In testing a given hypothesis, the maximum probability with which we would be willing to risk a type 1 error is called the level of significance of the test. This probability is denoted by alpha and is generally specified before any samples are drawn, so that the results obtained do not influence our choice. Now, it is customary to choose alpha equal to 0.5 or 0.01. If alpha equal to 0.05 or 5% is chosen in designing a test of hypothesis, then there are about 5 chances in 100 that we would reject the hypothesis when it should be accepted. That is, we are about 95% confident that we have made the right decision. In such a case, we say that the hypothesis has been rejected at a 0.05 level of significance, which means that we could be wrong with probability 0.05. Now, let us define simple hypothesis. It is a statistical hypothesis which completely specifies a parameter. Null hypothesis is always a simple hypothesis stated as an equality, specifying an exact value of the parameter. It includes any value not stated by alternative hypothesis. Null hypothesis is denoted by H naught, as we have seen earlier. So, mu equal to mu naught, means the population mean equals to a specified constant mu naught. Null hypothesis is equal to H naught, mu 1 minus mu 2 equal to delta. It means that the difference between the sample means equals to a constant delta. Now, let us discuss some composite hypothesis. Composite hypothesis is stated in terms of several possible values, that is by an inequality. Alternative hypothesis is a composite hypothesis involving statements expressed as inequalities such as less than, greater than, not equal to, because less than, greater than, not equal to will involve several values. Okay. So, alternative hypothesis is a composite hypothesis. Now, alternative hypothesis AH denotes alternative hypothesis. Alternative hypothesis we denote by H1. Okay. So, mu greater than mu naught. Okay. It involves infinitely many values. So, mu greater than mu naught or mu less than mu naught or mu equal not equal to mu naught, they are all alternative hypothesis. Now, in any test of hypothesis, a test statistic S star calculated from the sample data is used to accept or reject the null hypothesis of the test. Then we consider the area under the probability curve of the sampling distribution of the test statistic S star, which follows some given distribution. This area under the probability curve is divided into two regions, namely the region of rejection. The region of rejection is called as significant region or critical region, okay, where NH is rejected, and the region of acceptance, that is non-significant region. The region of rejection is called as the critical region, and then we have region of acceptance, that is called as non-significant region, where NH is accepted. So, thus the critical region is the region of rejection of NH. The area of the critical region equals to the level of significance alpha. Okay. The area of the critical region equals to the level of significance alpha. Note that the critical region always lies on the tails of the distribution. Depending on the nature of alternative hypothesis, critical region may lie on one side or both sides of the tails. Now, let us discuss the critical value or significant values. It is the value of the test statistic alpha S alpha star for given level of significance alpha. When you are given the level of significance alpha, from that we can decide the value of S alpha star. This S alpha star divides the area under the probability curve into critical or critical region and non-critical region. Critical region is the region of rejection, non-critical region is the region of acceptance. In the case of one-tailed test we denote by OTT Okay, two-tailed test we denote by TTT. So, right, let us say there are two one-tailed tests, right one-tailed test and left one-tailed test. So, right one-tailed test is the following: when the alternative hypothesis H1 is of greater than type, mu greater than mu naught or sigma 1 square greater than sigma 2 square, then the entire critical region of area alpha lies on the right side tail of the probability density curve, as shown in the following figure. You can see in the following figure this area, okay, this is the area which is equal to alpha, the level of significance alpha, and it lies to the right of the probability density curve. In such case, the test of hypothesis TOH is known as right one-tailed test. So, this area is alpha and the remaining area is 1 minus alpha. This is normal distribution. Now, in the case of left one-tailed test, when the alternative hypothesis H1 is of the less than type, that is mu 1 less than mu naught or sigma 1 square less than sigma 2 square, then the entire critical region of area alpha lies on the left side tail of the curve, as shown in this figure. You see, this is normal curve of the normal distribution. This area which is equal to alpha, the level of significance lies to the left of the probability density curve, and this is the test statistic S alpha star, which is decided from the level of significance alpha. Now, two-tailed test, if AH is not of the not equals type, that is mu 1 is not equal to mu naught or sigma 1 is not equal to sigma 2. When mu 1 is not equal to mu naught, we will have to consider both the cases, mu 1 less than mu naught, mu 1 greater than mu naught. So, there are there we have two-tailed test. Okay. So, then the CR region, critical region lies on both sides of the right and left tails of the curve, such as the CR of area alpha by 2 lies on the right tail and CR of area alpha by 2 lies on the left tail, because this is a curve symmetric with respect to y axis. So, half of the area of the curve lies on one side, half lies on the other side. So, the total area under the curve for the level of significance is alpha. So, alpha by 2 lies to the left of the curve, to the left side, and alpha by 2 lies to the right of the right side. So, this is your alpha by 2 area, and this area is alpha by 2, and this is minus S star alpha by 2, this is minus S star alpha by plus S star alpha by 2. Now, let us discuss test of hypothesis concerning single population mean. Let us consider a single population, okay, and we discuss test of hypothesis concerning the single population with mean mu and known variance sigma square. So, let mu and sigma square be the mean and variance of the population from which a random sample of size n is drawn. Now, let x bar be the mean of the sample, then for large samples, that is n greater than or equal to 30, from central limit theorem it follows that the sampling distribution of x bar is approximately normally distributed with mean mu x bar equal to mu and sigma x bar equal to sigma square by n. Okay. The test statistic for single mean with known variance is z equal to x bar minus mu naught divided by sigma by root n. Okay, this is the curve. Here it is two-tailed test. So, that means alpha by 2 is area is here, alpha by 2 area is here. This is the value of z for this alpha by 2 area, be noted by minus z alpha by 2, and this is the value of z here plus z alpha by 2 for this alpha by 2 area which lies on the right side. Okay, this is mu naught. Okay. So, this is negative critical value minus z alpha by 2, this is positive critical value z alpha by 2 on the z scale. Okay. This is acceptable region, the value this region is the region of acceptance, and this is the region where your H naught is rejected. Okay. The null hypothesis is rejected, here in this portion null hypothesis is accepted. So, the region where the null hypothesis is rejected is called the critical region. So, this region and this region, they are critical region, okay. They are called significant regions, and this is called non-significant region where the null hypothesis H naught is accepted. let us compute the we will compute the test statistic Z by Z equal to x bar minus mu naught over sigma by root n, where x bar is the mean of the sample of size n, it is calculated from the sample data. Now, how we will conclude? We will reject the null hypothesis H naught if Z falls in the critical region. Okay, if Z falls in the critical region, that is observed sample statistic is probably significant. Okay, if Z falls in the critical region, then the null hypothesis will be rejected. Okay, so that region is called as significant region. So the observed sample statistic is probably significant or highly significant at alpha level of acceptance. Otherwise, we accept H naught, and we will accept H naught if minus Z alpha by 2 is less than Z alpha by 2 in the case of two-tailed test. The following table gives critical values of Z for both one-tailed and two-tailed tests at various levels of significance. Now, this table this is the critical value of Z for one-tailed test. It is 0.10, if alpha is 0.10, it is minus 1.28 or plus 1.28. If it is alpha is 0.05, it is minus 1.645 or plus 1.645. Likewise, we have for alpha equal to 0.01, alpha equal to 0.005, alpha equal to 0.002, and when we have two-tailed test we have to apply, then when alpha is equal to 0.10, critical values are minus 1.645 plus 1.645, and for 0.05 they are minus 1.96 and plus 1.96 and so on. For alpha equal to 0.002 they are minus 3.08 and plus 3.08. Now, let us see how we will make the test of hypothesis. The test of hypothesis or test of significance or rule of decision consists of the 6 steps. So, we first formulate the null hypothesis H naught, then we formulate the alternative hypothesis H1, okay. Then we choose the level of significance alpha, then the critical region CR is determined by the critical value S alpha star, okay, and the kind of AH based on which the test is or right one-tailed test or left one-tailed test or two-tailed test. Okay. So, this has to be decided. They compute the test statistic S star using the sample data, then accept or reject NH, null hypothesis NH, depending on the relation between S star and S alpha star. Now, let us consider the length of life x of a certain computer is approximately normally distributed with mean 800 hours and standard deviation 40 hours. If a random sample of 30 computers has an average life of 788 hours, test the null hypothesis that mu is equal to 800 hours. So, null hypothesis NH that is H naught is mu equal to mu naught equal to 800 hours. Mu equal to mu naught equal to 800 hours against the alternative hypothesis that mu is not equal to 800 hours. So, alternative hypothesis is H1 is mu not equal to 800 hours. Okay. Now, we are given n is equal to sample of size is 30. So, n is equal to 30 we are given. Okay. X bar random sample of size 30 computers has an average of 788 hours. So, x bar is equal to 788. So, we know x bar, we know mu naught, we know sigma is equal to 40 hours. So, let us calculate the value of z is equal to x bar minus mu naught divided by sigma by root n. So, this is 788 minus 800 divided by sigma is 40 divided by root 30. So, this is equal to minus 12 divided by 40 root 30. Okay. So, this is minus 0.3, this is divided by root 30. Okay, so minus 0.3 into root 30. Okay, so this comes out to be minus 1.643. Okay, now what we have alpha equal to 0.5%. Alpha is given to be 0.5%. So this is equal to 0.005. Okay, now and this is mu is not equal to 800 hours. So it is a two-tailed test we have to apply. Okay, two-tailed test we have to apply. So let us see for two-tailed test, when alpha is equal to 0.005. When alpha is 0.005, critical values for Z are minus 2.81. Okay, so minus 2.81 we have. Okay, so the critical values of Z are minus 2.81 and plus 2.81. Okay, now this is approximately normally distributed. So we can see here okay, so this is minus 2.81 and this is plus 2.81. This is the critical region. Here we are getting the value minus 1.643. Okay, 1.643 means this value of Z lies in the region of acceptance. Okay, since minus 1.643 is greater than minus 2.81. Okay, the null hypothesis is accepted. This is region of rejection, that is critical region. This one, this is alpha by 2, this is alpha by 2, this is critical region, and this is region of acceptance, non-significant region. So Z equal to minus 1.643. Okay, this is greater than this value of minus 2.81. So we have the result that null hypothesis is accepted at 0.5% level of significance. Now when alpha is equal to 1%, okay, alpha equal to 1%, then what happens? Let us see. So alpha equal to 1% means alpha equal to 0.01. Then the critical values of Z are minus 2.58 and plus 2.58. So here the critical values are minus 2.58 and plus 2.58, and now minus 2 alpha, now this Z, okay, this computed value of Z is minus 1.643, minus 1.643 is also greater than minus 2.58. Okay, so again null hypothesis is accepted. Again null hypothesis is accepted. Now let us consider the third case when alpha is equal to 15%. So alpha equal to 15% means alpha is equal to 0.15. Okay. So in this case what will happen? 0.15 area, okay, will lie under the probability density curve. So half of this 0.15 area will lie to the left, half will lie to the right. Okay. So this will be 0.075. Okay, and here also it will be 0.075. Okay. So alpha by 2 area lies on this side, alpha by 2 lies on this side, that is 0.15 by 2 means 0.075 lies on each side. Now for this 0.075, the value of Z is critical value of Z is minus 1.44. Okay. So critical values of Z critical values of Z are minus 1.44 and 1.44. Okay. So, in the C part, okay, what is happening is the critical values of Z are minus 1.44 and plus 1.44, and we notice that minus 1.643 is less than minus 1.44. Okay. So, minus 1.643 is less than minus 1.444. Minus 1.643 is less than minus 1.44, and therefore, the value of Z minus 1.643 lies in the critical region. Okay. So, the null hypothesis is rejected, that is, we accept the alternative hypothesis. So, here null hypothesis is rejected. So, null hypothesis is rejected in the C case. Okay. So, in the case A, where alpha is 0.005, null hypothesis is accepted. In the case alpha equal to 0.01, null hypothesis is again accepted. When alpha is equal to 0.15, since the critical value of Z is more than the value of Z which is calculated from the data, that is minus 1.643, okay, the null hypothesis is rejected. Okay. So, in the A and B part we are accepting the null hypothesis, in the C part we are rejecting the hypothesis. Now, let us consider example 2. Mice with an average lifespan of 32 months will live up to 40 months when fed by a certain nutritious food. If 64 mice fed on this diet have an average lifespan of 38 months. So, x bar here is 38, sigma is for 5.8, n is equal to 64. Now, we have to test, is there any reason to believe that average lifespan of mice is less than 40 months. So, mu null hypothesis is that mu is equal to 40, okay, while alternative hypothesis is that mu is less than 40. So, since mu is less than mu naught, it is left tailed test, left one tailed test. So, LOTT. So, LOTT we have to apply, and it is customary to take alpha equal to 0.05 or 0.01. So, let us take alpha equal to 0.01. So, level of significance we are taking to be 0.01. So, let us take alpha equal to 0.01. Okay. Now, let us calculate the value of Z from x bar minus mu naught divided by sigma over root n. So, x bar is equal to 38 minus mu naught is equal to 40 divided by sigma is equal to 5.8 and then divided by root 64. So, we have minus 2 here multiplied by root 64 is 8. So, minus 16 divided by 5.8, okay, and this comes out to be okay. So, roughly it is minus 2.76, okay, approximately. So, now, for alpha equal to 0.01 in the case of LOTT, let us find the value of Z. Okay. So, this can be seen from this table 0.01, okay. For one tail test it is minus 2.33, okay, left one tail test. So, minus 2.33, let us see the critical value of Z is minus 2.33 and this is minus 2.76. So, since minus 2.76 is less than minus 2.33, okay. So, this is our critical region, or not here, on the left side only. So, this the critical region lies to the left side only. So, this is the critical region is alpha equal to 0.01 and the value of z is minus 2.33 critical value, and z is equal to calculated value is minus 2.76. So, this is less than minus 2.76 is less than minus 2.33. So, we are in the critical region. Okay. So, it follows that H naught is rejected, meaning that H1 is accepted, alternative hypothesis is accepted, and alternative hypothesis is that mu is less than 40. That means, there is reason to believe that the average life span is less than 40 months. Okay. So, that is the conclusion, that there is reason to believe that the average lifespan of mice when fed by a certain nutritious food is less than 40 months. Now, let us discuss a machine runs on an average of 125 hours per year, a random sample of 49 machines. So, n is equal to 49, has an annual average use of 126.9 hours. So, x bar is equal to 126.9 with standard deviation sigma is equal to 8.4. Does this suggest to believe that machines are used on the average more than 125 hours? So, mu is null hypothesis H naught is mu equal to 125 hours. Mu naught is 125 hours. H1 alternative hypothesis is that mu is more than 125 hours. Okay. They are used on the average more than 125 hours. So, mu is greater than 125. So, since we have mu greater than 125, this is right one tail test we have to apply. Okay, right one tail test we have to apply. Now, let us calculate alpha is given to be here 0.05. At 0.05 level of significance, we have to see we have to test our hypothesis. Now, let us say find the value of z. Z is equal to x bar minus mu naught divided by sigma over root n. So, x bar is equal to 126.9 minus mu naught is 125 divided by sigma is equal to 8.4 divided by root n, n is equal to 49. So, we have this. So, this is minus plus 1.9 divided by 8.4 over 7. Okay. So, this is how much 1.9 into 7 divided by 8.4. So, this is 13.3 divided by 8.4. So, 133 divided by 84. So, roughly 1.58. Okay. This is 1.58. Now, let us see at 0.05 level of significance what is the value of z, okay, from the table critical value of z. We have alpha equal to 0.05, okay, and critical value of z is 1.645, okay, 1.645. So, here critical value of z 1.645. Now, 1.645 is greater than 1.58. Okay. So, since 1.58 is less than 1.645. Okay. So, this value of z lies in the region of acceptance. Okay. So, the null hypothesis is accepted. Okay, because you can see this is your curve, this we are applying right tailed test. Okay. So, this area is 0.05, this area is 0.05 and we have found the value of critical value of Z as 1.645. 1.645. So, 1.645 critical value of Z is here 1.645. Okay. Sorry, critical value of Z we have found to be 1.645. So, okay, this is 1.645. Okay, this value is 1.645. Okay, 1.58 is here. So, it lies in the region of acceptance. It lies in the region of acceptance. So, null hypothesis is accepted. This means that alternative hypothesis is rejected. Okay. So, this mu is greater than 125. Okay, mu is greater than. So, alternative hypothesis is rejected. Okay. That is to say that machines does this suggest to believe that machines are used on the average more than 125 hours annually. Okay. This is not accepted. Okay. So, machines are not used on an average more than 125 hours annually at 0.05 level of significance. Now, the mean lifetime of a sample of 100 fluorescent light bulbs produced by a company is computed to be 1570 hours. So, x bar is equal to 1570 hours. With a standard deviation sigma is equal to 120 hours. We have mu equal to mu is the mean lifetime of all the bulbs produced by the company. Test the hypothesis mu equal to 16 hours. So, we have a null hypothesis mu equal to 1600 hours. So, this is my mu naught. Okay. And then again the alternative hypothesis that mu is not equal to 1600. So, we are considering two-tailed test, that is TTT, because we are taking mu not equal to 1600 hours. And now, let us find the value of Z. So, Z is equal to 1570 minus 1600 divided by sigma. Sigma is given to be 120 divided by root 100, because there are 100 bulbs. Okay. So, how much is this? This is minus 30 divided by 120 and then we have 10 here. So, this is 2.5, right, minus 2.5. Okay. So, sigma comes Z comes out to be minus 2.5. Now, let us see for the two-tailed test what are the critical values of Z on the level of significance 0.05 and 0.01. Okay. So, at 0.05 0.05 for the two-tailed test the values, critical values are minus 1.96 and plus 1.96. So, critical values at alpha equal to 0.05, critical values are minus 1.96 and plus 1.96. Okay. Now, we can see since minus 2.5 is less than minus 1.96. Okay. This is critical value minus 1.96 and this is 1.96. Okay. This area alpha by 2, this area is alpha by 2. Okay. Now, minus 2.5 lies here somewhere. So, minus 2.5 is less than minus 1.96 and therefore, this is region of rejection of H naught. Okay. So, H naught is rejected. Okay. Null hypothesis, that is mu is not equal to 1600 hours is rejected. This is called critical region. Okay. So, since this value computed value minus 2.5 lies here, okay, it follows that H naught is rejected at 0.05 level of significance, at 0.05 level of significance. Okay. Now, if I take 0.01, then what happens? 0.01, the values of Z are minus 2.58 and 2.58. So, at alpha equal to 0.01, okay, critical values are minus 2.58 and plus 2.58. Okay. Now, minus 2.58 is less than minus 2.5. So, since minus 2.5 is greater than minus 2.58, okay, we can draw the figure. This is minus 2.58, this is plus 2.58. Alpha by 2 area is here, alpha by 2 area is here, and minus 2.5 is here. So, since minus 2.5 is more than minus 2.5, okay, 58, okay, it follows that we are in the region of acceptance of the null hypothesis. So, H naught is accepted. And so, the alternative hypothesis is rejected. Okay. So, the mean mu equal to 1600 hours is the mean life of the mu equal to 1600 hours is accepted at 0.01 level of significance, while in the case of 0.05 level of significance, mu equal to 1600 hours is rejected. So, this is what I had to say in this lecture. Thank you very much for your attention.